Hello everyone. Welcome back to another exciting session on conic sections. Now tell me, have you ever noticed how a satellite dish, a car headlight, or even a waterfall seems to have a similar curve shape? Well, surprise. That shape isn't random. It's mathematical. It's called a parabola. So, what exactly is a parabola? Let's imagine this. There's a fixed point called the focus and a fixed line called the directrix. Now, if we take every point that is equally distant from both, tada, the shape we get is our beloved parabola. The line passing through the focus and perpendicular to the directrix is called the axis. The point where the parabola cuts this axis is its vertex, and that's like the hinge or turning point of the curve. If the focus ever lies on the directrix, well, the parabola collapses into just a straight line. That's what we call a degenerate parabola. In short, a parabola is like a curve that can't decide whether to stay flat or shoot off to infinity. So it does both beautifully. Alright, let's derive the most famous parabola equation. The one every student meets first. Y squared equals 4ax. Let's set up our coordinate plane. Place the vertex at the origin. That's the point 0, 0. Let the focus be at A, 0, on the positive x-axis, and the directrix be the vertical line x equals -a. Now, pick any point P with coordinates x, y on the parabola. By definition, the distance of P from the focus must be equal to its perpendicular distance from the directrix. So, using the distance formula, the distance from P to F, written as PF, is PF equals square root of bracket x minus a squared plus y squared bracket close. The distance from P to the directrix is simply x plus a. So, according to the definition, we write square root of bracket x minus a squared plus y squared bracket close equals x plus a. Now, to remove the square root, we square both sides. That gives us x minus a squared plus y squared equals x plus a squared. Let's expand both sides. On the left, x squared minus 2ax plus a squared plus y squared. On the right, x squared plus 2ax plus a squared. Now simplify. Cancel x squared and a squared from both sides. We are left with y squared equals 4ax. And there you have it. The simplest, cleanest, most elegant equation of a parabola with its vertex at the origin and opening to the right. If I is greater than 0, the parabola opens rightward. If I is less than 0, it opens leftward. So yes, the sign of A decides whether the parabola is a morning stretch to the right or an evening bend to the left. Now, not every parabola faces the same way. Depending on which axis it opens along, the equations look slightly different. Let's see them all. Y squared is equal to 4ax opens rightward, y squared is equal to minus 4ax opens leftward, x squared is equal to 4ay opens upward, x squared is equal to minus 4ay opens downward here. A represents the distance between the vertex and the focus. Whenever y is squared, the axis is horizontal. Whenever x is squared, the axis is vertical. So, think of it this way. The variable that's squared just tells the other variable, hey, you be the direction I open in. Now let's talk about something interesting. The Latus Rectum. Sounds fancy, right? It's just the line segment through the focus, perpendicular to the axis of the parabola. For the standard parabola y squared is equal to 4ax, the focus is at a, 0. If we put x is equal to a into the equation, we get y square is equal to 4a times a is equal to 4a square. So y is equal to plus 2a and y is equal to minus 2a. That means the endpoints of the Latus Rectum are a, 2a and a minus 2a. Hence, the length of the Latus Rectum is equal to 4a. So the bigger the value of a, the wider your parabola's mouth opens. Like a hungry Pac-Man waiting for a math snack. And in real life, that same idea is used in designing headlights and satellite dishes. The wider the curve, the broader the reflection of signals or light. Let's now learn how to recognize a parabola when it's hiding inside a general conic equation. A general second-degree equation looks like this. ax squared plus bx y plus c y squared plus dx plus e y plus f equals 0. Now here's the trick. If only one variable is squared, or if the discriminant, that's b squared minus 4 is c, equals 0, then congratulations, it's a parabola. For example, take this equation, y squared plus 2gx plus 2fy plus c equals 0. Let's rearrange it so the squared term is isolated. Y squared equals negative 2gx minus 2fy minus c. Now, by using the method of completing the square and then shifting the origin to a new point, we can rewrite this in the standard form. Y squared equals 4 into bracket x minus h bracket close. Here, h, k represents the new vertex of the parabola. In short, just move the vertex to the origin, simplify your equation neatly, and you'll see the parabola reveal itself like magic. It's like dusting an old mirror. The shape was always there, you just had to clear away a little algebra to see it shine. Now let's generalize the parabola. What if the focus and directrix aren't aligned neatly along the x-axis or y-axis? Let's say the focus is at the point P, Q, and the directrix is the line ux plus v y plus w equals 0. For any point P, x, y on the parabola, the distance from P to the focus must equal its perpendicular distance from the directrix. So we write square root of bracket x minus p squared plus y minus q squared bracket close equals modulus of bracket ux plus v y plus w bracket close divided by square root of bracket u squared plus v squared bracket close. Now, let's square both sides to remove the square root. That gives us x minus p squared plus y minus q squared equals ux plus v y plus w squared divided by u squared plus v squared. If we expand and simplify this expression, we arrive at the general second-degree equation of a parabola. And here's the most important part. For every parabola, the discriminant satisfies the condition. Alright, let's apply what we've learned with a couple of examples. Example 1. The equation is y squared equals 8x. Compare it with the standard form y squared equals 4ax. From this, we can see that 4 equals 8, so equals 2. Hence, focus is equal to 2, 0. Directrix is equal to x equals negative 2 and the Latus Rectum is equal to 4a is equal to 8 units. Example 2. If the vertex is at 0, 0 and the focus is at 0, 2, then the axis is along the y-axis. Using the standard form x squared equals 4ay, we substitute a equals 2, giving the equation x squared equals 8y, common mistakes, mixing up the sign of a. Remember, the sign of a decides the direction of opening. If a is positive, it opens in a positive axis direction. If a is negative, it opens the other way. Forgetting domain restrictions. For y squared equals 4ax, when a is greater than 0, x must be greater than or equal to 0. Applications. From telescopes to solar cookers, parabolas are everywhere. Their special shape allows them to focus light, sound, or energy to a single point, the focus, making them the true superstars of geometry and physics. So, to wrap it all up, a parabola is that one special conic with just one square term, one focus, one directrix, and an infinite number of applications. And now that you know how to derive it, identify it, and interpret it, you've officially mastered the curve that helps us light up cities, send signals, and even cook our food. In our next video, we'll stretch things out a bit, literally, as we explore the ellipse, the elegant cousin of the circle and the parabola. Until then, keep your focus sharp, your direction clear, and your math perfectly curved.